Hello, we're continuing with life science and cell biology in a nutshell. We're learning currently about the Golgi Apparatus, which is a group of folds or stacks. It is used for the packaging and preparing of molecules to be shuffled around the cell, either inside or to be secreted to the outside of the cell. It's in charge of delivering molecules to their target destinations, which may be on the inside of the cell, on various cell membranes of the either of the entire cell membrane, or membranes of different organelles, or to the lysosomes, or to the outside of the cell. Some molecules, including certain soluble proteins and secretory proteins, are carried in vesicles to the cell membrane for exocytosis or release into the extracellular environment. Exocytosis of secretory proteins may be regulated, whereby a ligand must bind to a receptor to trigger vesicle fusion and protein secretion. Soluble and secretory proteins leaving the Golgi apparatus undergo exocytosis. The secretion of soluble proteins occurs constitutively. In contrast, the exocytosis of secretory proteins is a highly regulated process in which a ligand must bind to a receptor to trigger vesicle fusion and protein secretion. Vesicular transport model is the idea that vesicles bud off and fuse to cisternae membranes, moving molecules from one cisternae to the next. Budding vesicles can also be used to transport molecules back to the endoplasmic reticulum. A vital element of this model is that the cisternae themselves are stationary. The cisternal maturation model indicates that cisternae move forward and mature into transcisternae, with new cis-cisternae forming from the fusion of vesicles at the cis phase. In this model, vesicles are formed but are used only to transport molecules back to the endoplasmic reticulum. The Golgi apparatus was observed in 1897 by Italian cytologist Camillo Golgi. Here's a micrograph showing an animal cell, the cisternae of Golgi apparatus, nucleus. So outside the nucleus, you have the ER, endoplasmic reticulum, as we saw earlier. Also here, and this goes outward from the rough endoplasmic reticulum to the smooth endoplasmic reticulum. So in the rough, you have protein synthesis. In the smooth, you have lipid and steroid synthesis, and as well as breakdown. And in the outermost folds, you have contact with the Golgi apparatus, which are more folds where the proteins and molecules that need to be moved around are packaged for delivery to various locations, either within or outside the cell. So here again, showing the folds in micrograph. Transport vesicles are used to move molecules, proteins, lipids, whatever needs to be moved. So cis phase is the phase closest to the endoplasmic reticulum, receiving proteins and lipids. The trans phase is the quote unquote shipping site of where the Golgi apparatus will take these molecules and send them. So molecules are tagged with certain tags or modified in a way where the molecule will be destined to a certain specific location, either within or outside, for export either to the membrane of the cell, for export to various locations within the cell, to certain organelles or wherever they need to be going. So showing folds of the Golgi apparatus. Here is one. These are the Golgi stacks. The vesicles, which are budding off, containing molecules that are moved. Plant Golgi apparatus. Showing the 3D Golgi stacks and the vesicles, which are secreted used for transport of various molecules. So various tags can be either carbohydrate groups added, fatty acids added, phosphorylation. So various modifications of molecules occur in the Golgi in order to mark them for their specific locations that they're transported to. So the Golgi again is stacks of flat sacs, receives vesicle-bound proteins from the RER, the rough endoplasmic reticulum, distributes them to other organelles or out of the cell. It is a receiving, processing, and packaging and shipping organelle. So the Golgi body or complex, also called dictysome. So it uses vesicles. It is the post office of the cell, composed of many membranous sacs or vesicles. These folds called cisternae. It has the cis or receiving and trans or shipping faces. So the cis is the closest to the ER. Trans is more closer to the outer membrane of the cell, the cytosol. It modifies and concentrates proteins and lipids from the endoplasmic reticulum, tags them for delivery, aka an address. Vesicles bud off, send these molecules. Some vesicles may become lysosomes, which are used for breakdown of molecules. We'll learn about that in a bit. Some vesicles may join the plasma membrane in order for the molecules to be secreted outside of the cell. So cis and trans sacs and vesicles. So this is showing the vesicles, what they would look like, and budding off of the folds of the Golgi. So the folds, cis and trans, and vesicle for transport.